The important probability distribution is the binomial distribution. So what is binomial distribution? So in case of the binomial distribution, a fixed number of observation means trials you have some fixed number of observation. So you can say that you have n trials, like you are tossing the coin n times. So you have the trials, number of trials, like 15 tosses of a coin. So you have the fixed number of observations. Now 20 patients you are going to observe. This can also be. There are 1,000 people surveyed. Now the important thing is that for every all these observations or trials, we have the outcome which is the binary one. Means you are tossing a coin, and now if you are tossing a coin, then it can be head or tail. So you can say that it is head or tail, like success or failure, you can say. So head and tail. 20 patients, like if you have the patients, you are observing the patients, and maybe for some kind of disease. So patients may have disease or not disease. So this is the case of the binary thing, either disease or no disease. So head or tail in each case, tossing a coin. So this is generally called outcome is 2 means binary, and the fact success and failure we sometimes call. Probability of success is p and probability of failure is 1 minus p. It is so you have the two outcomes only, like you have the two outcome, one is the head and one is the tail. So if head is not coming, then tail is coming. So success and failure. So probability for if success for coming head, if you denote by success p, then probability for this is what? 1 minus p. For some other cases, if you know that probability is for some other cases is 0.7, then you can know the other part of the probability 0.3. So if you have the two outcomes, then you have the outcome for coming for the outcome one is this, coming for outcome next is this. One thing is important. If you go for the binomial distribution, then you have to observe that probability, constant probability for each observation. If you are tossing a coin first time, the probability for head and tail is remains same, 0.5. If you are tossing second time also, then for coming head and tail, again probability for head or tail is again 0.5. If you third time, then again head and tail, again head and tail comes with the probability of 0.5. So this is the constant probability, means probability is not going to change once you are going to repeat the observation or track. So this is once you go for the binomial distribution, then you have to remember three things. One is that you have the some fixed number of trials. This is one thing. Second, you have the binary outcome. Okay, you have the two outcomes in that every time you have the two observation. So if one is not coming, then other is coming. So if you know the probability for one, you can determine the probability for others. And every time you repeat the experiment, then the probability is constant, means it is not going to change. Whatever you have done at the first time, if you are repeating in the another time also, then the probability remains same. So this is three observations you have. Let us, if you have the n independent repetitions or trials of a random experiment, if A is an event associated with E such that if A is an event associated with the experiment E such that probability for this event A remains the same for the repetition, means it is constant, just like tossing head and tossing coin. The trials are called the Bernoulli trials. So this is known as the Bernoulli trials. So if you have the 5 coin tosses, then what's the probability that you keep exactly 3 heads in 5 coin tosses? You can determine. You have the how many times you have tossed the coin? 5 times. And the 5 time coin tosses, you have probability that you have 3 heads. You have observed 3 heads. in 5 coin tosses. You need to determine. So see that every time you toss a coin, you have the probability for head and tail is fixed, means this is the constant. Number of observation is fixed. How many times? 5 times you are going to toss coin. And here probability is not going to change. And what you have? It is probability is constant, means it is constant. So and outcome is what? 2 only, either head or tail. So you can apply, you can go for the binomial distribution. So how you can go for the binomial distributions? So first look at the solution. So one way to get exactly 3 heads is like this. Means you are tossing a coin, first time is head, second time is also head, third time is also head. And then you are tossing 5 times and you have the 5 times. So first 3 times head and next 2 times are tails. Then what is the probability of getting 3 heads in this combination? 1 by 2 multiplied by 1 by 2 multiplied by 1 by 2 means this. Then for this also 1 by 2 and 1 by 2. This is 1 by 32. So okay, for getting the answer of such for one combinations, you know that like we have computed probability for the head multiplied by probability of the head, then probability of the tails, probability of the tails, and 1 by 2 is the probability of head. How many times it comes? 3 times. 1 2 3. So power is 3. 1 by 2 square. This is another way. T dot T H H H T. For this combination also, you have the 1 by 2 raised power 3 multiplied by 1 by 2 square. So always you will have the 2 tail and 3 heads. So in every combination where you have the 3 heads, you will get the same value. So actually you need to determine how many such combinations are there. So 1 by 2 raised power 3 multiplied by 1 by 2 raised power 2. This is the probability of each unique outcome that has the exactly 3 heads and 2 tails. So this is. So we have to determine the probability for coming the 3 heads in the 5 trials. This is good. So you have to see for the all possible combinations. So the overall probability for 3 heads and 2 tails, you can say like this. This is for one arrangement. This is for the next arrangement. This is for the next arrangement. Means you have to find out how many such arrangements are there for every unique arrangements. But how many are there? You have to determine. See, what are the total arrangements? If you are tossing a coin 5 times, how many such arrangements are there? It can be this also. Every time tail can appear, or you can have the like this. This can also be there, or this. So you have the 2 raised power 5. Just like starting from the 0 0 0 0, and you are going for the 1 1 1 1 1. So all tail starting from the all tail to the all head. And this is how many tuples are there? 2 raised power 5. So 32. You have the 32. And now you need to determine how many out of these 32, how many combinations, in how many combinations we have exactly 3 heads. This is one combination, we have the 3 heads. In other combination may be possible like this, H, T, T, H. This can also be possible. So this is also, so you have to determine the total combinations. So when you have to use for the concept of the combinations, out of the 5, you have to select the 3 combination. You have to select the 3 heads. We are interested for the 3 heads. Like out of 5 people, you are forming a committee of 3 persons like this. So how many such combination how many ways you can form the committee? So this is also so out of 5, You need, out of 5 coin tosses, you have 3 hits. You need 3 hits. So total, and order is not important. So you have the five C3. So you have the 10 combinations. These are the all such combinations. So you have the 5C3. So ways to arrange the 3 hits in the 5 tries. So like this is one possible combination, like other, like this. These are the 10 possible arrangements. And every time we have the probability for the 10 arrangement is what? This is. So and this is so this plus this plus this, how many times? 10 times. 10 times means 5C3. So somebody say that you are 20 times you are tossing a coin. 20 times you are tossing a coin, and the probability for appearing 5 times head, 5 heads. So how can you determine the 5 heads out of 20? So 20C5 you have to determine. These are the all possible combinations you have, and every time, what is the, you have the 5 out of the 20. You have the 5 times heads. The probability of 5 times head is 1 by 2 raised to power 5. Multiply by remaining, you will have the tail. So how many times tail comes? 1 by 2 multiply by 15. And actually from this you can have the, this is the formula APS. So this is, whenever you go for the binomial distribution, then you will find the formula like this: number of trials, and then you have the success, how many success you want. You can say how many success. Now success means head, for example, 5 times head. So okay, 5 times. So this is the total combination, and since your out probability is going to fix every time you are repeating the experiment, so you need to determine actually. So you have to determine, you will have the probability for the success and you will have the probability for failure. So this is the heads. So this is the same thing. It is probability for the heads, rest is power 3, because 3 times you know success, and probability for the tails, and 2 times you will have. And this is the 10 by 32, and this is like this. Okay. Now this is the binomial distribution function, the number of heads tosses in 5 coins. So you are tossing a coin 5 times, number of times head appears. So number of times head appears means 0 times head appears. So you can determine 0 times head will appear 0 times. So means all T you have, all tails. Then 1 times head appears, then this, then this, then. You can determine in the same way. Okay. So you can say that just you have the 5 trials and you have this 0 times success you have head. And probability of 1 by 2, 0. And probability of coming tail is 1 by 2 and 5 minus 0. So this way you can compute the probability. Now see the formula. So here x is the success, number of success, and p denotes the probability. So here it says that p denotes the probability for the success. Okay, so probability for the success, it is going to denote by p, and okay, how many success are there? So it is denoted by the x. Then the probability for exactly x success means probability, this is the number of success, and p denotes the probability of success. So probability of failure is this. So how many total observations? You have the n observation. So like you have the n toss of coins. So you have the situation, the number of trials. X denotes the success, number of success out of the n trials. So you have the n trials, and out of n you have the x success. Probability of success is the probability of success. Like earlier 1 by 2, we have the probability of, and how many this success comes? How many hits? How many times hit comes? Like 3 times. And this is the 1 minus p, probability of failure. This is, actually, this is the Bernoulli theorem. So binomial, with the help of this formula, you can easily, if four heads, somebody says that four heads comes, how you can say that? You have the how many tiles you have the n. This is 5, c, and 4. Number of times heads comes 4. This is, then probability for the success means coming head, probability of coming head is 1 by 2. How many success are there? 4 times success. So 4 times success multiply by probability of failure is 1 minus 1 by 2. This means 1 by 2. How many times this failure comes? The number of times success comes is 4. And how many trials are there? 5. So 5 minus, so n minus x means 5 minus 4. This is 1. And this is the answer. So with the help of this formula, you can easily compute. If I toss a coin 20 times, number of trials, how many times hit comes? 10 times. So number of times success comes this. Probability of success is this. Number of times success comes this. Number probability of failure is 1 minus probability of success this. Number of times failure comes 10 times because 20 times you have tossed. 20 minus 10, and this is like this. If I toss a 20 times coin 20 times, what's the probability of getting a 2 or fewer heads? Means probability of getting how many heads? Either 0 or 1, 2. Means you have to find it. What is the probability of getting 0 heads? What is the probability of getting 1 heads? What is the probability of getting 2 heads? Then you find the summation. So this is the probability of getting 0 heads, like this. So this is the way you can say like this. So probability of getting 0 hit, 20 c, number of times 20, 0, number of success 0, probability of success, number of times success comes 0, probability of failure, number of times failure comes this, and this is the basis. So this is one. You can solve and you will get the answer like this. Now you have to 8 plus 2 or less. So number of times hit comes 1 times, 20 c 1. How many times success comes? 1 times. How many times failure comes? 19 times. And this is the answer. Plus, this is the probability. Plus 20 times tossing the coin. Number of times success comes to probability of success. Number of times success. Probability of failure. Number of times failures comes 18 times. And you can solve it and you are getting this. And once you find the summation, this plus this plus this, and this comes out this. So this is the use of your binomial distribution formula, Bernoulli theorems. So again, all probability distributions are characterized by unexpected values and a variance. So if x follows a binomial distribution, if you have the binomial distribution and you are given that the number of trials is this and probability for success is this, and somebody asks you that what is the expected value, means what is the mean, then you just multiply the number of trials with the probability for the success. And if you want to determine the variance, then you just multiply the number of these three things: number of trials, probability for the success, multiply with probability for the failure. This is for the success and this is for the failure. And once you go for the standard deviation, then you have to make the square root of this. So you can compute the standard deviation by making the square root of the variance. So simply use the formula whenever you have the binomial distribution. Variance always lie between 0 times n to 0.25 times n. Why it is so? The probability can be equal to 0, or it can be less than or equal to 1, because this is the probability. If it is 0, then this will become 0 and whole things will be, this becomes 0, and 0 you are going to multiply with n. So 0 multiply with n. This is the minimum value. What is the maximum? When this will come maximum? When you have p is equal to 0.5. When p is equal to 0.5 comes, then this will be maximum. Like p is 0.5, 1 minus 0.5. So this you are getting maximum value. If p is If one is more and one is other was less, say if success is, say for example 7, and then f will zero point 0.7 and then 0.3, then this is 0.21. But if you have the probability for the success is 0.5, probability of failure will also be 0.5, then you have 2. So this is the maximum value, is the maximum value you get when the p is 0.5, and that's why if p is 0.5, then 0.5 multiplied by 0.5, this is the 0.25, 0.25 multiplied by the number of trials n. So your variance will come from within this range from here to here. Cohort study means group study, you know. Sometimes people are observing the particular groups, how they are growing and what. So this is known as the cohort study. So if you are performing a cohort study, if the probability of developing a disease in the exposed group is 0.05, ये आपका important. So you are going to perform a cohort study. If probability of developing disease in the exposed group is 0.05 for the study duration, okay, then if you randomly sample 500 exposed people, you are testing 500 exposed people, how many do you expect develop the disease? So outcome is what? Either disease or no disease. So this is the case of the binary outcome. You have the 500 people you are going to observe, okay. So n here is what? N is here, n is 500. So this is n is 500, and for the success, probability for the success is what? Probability for the success is actually the probability for the disease. So this is the say you are performing a cohort study if the probability of developing a disease in exposed group is 0.5. This is the probability for success. So probability, you are selecting a people, and what is the probability that he is going to have the disease is 0.05. So this is the case. So now you have found the p value, and you have found the n values. So p is equal to 0.05 and n is equal to 500. You have the 500. So you are how many? 500 exposed people you are going to test, and how many do you expect to develop the disease? This is one thing. So how many do you expect this? How many do you expect? So and second question says that what's the probability that at most 10 exposed people develop the disease? So now you can answer like this. How many do you expect to develop the disease given a margin error this like this. So see that how many do you expect? So expectation. So how you can compute the expectation means this is the average value, and you know that in the binomial distribution this is the n and this is the p. So when you have the n and p values, then you can find the expectation. So how you can find the expectation? This is the expectation ex means average. So how many do you expect to develop a disease? The probability of disease, you know that 0.05, and the number of people you are going to observe is 500. So you have found the n and p values, and expectation, we have seen the formula for the expectation. In case of the polynomial is np. This is the np. So n is this and p is this, and just multiply. Variance, how you can compute the variance? For computing the variance, we need a formula which is the n multiplied by the p multiplied by 1 minus p. So probability of success, probability of failure. So 500 people are there. Probability for disease is 0.05. Not disease, disease, no disease means failure. No disease, 0.95. So this is equal to this. So variance is like this, and standard deviation is this. You can find the square root of this, and you can find this standard deviation. And this is the plus minus standard deviation for your estimate. So this is the estimate is 25, and you have the plus minus this. So this is the answer for the first part. Now, how can you answer for the second one? What's the probability that at most 10 exposed subjects develop the disease? At most 10. So this is asking for a cumulative probability. Probability means you have to add the probability of zero getting the disease means no one has the disease, or 1 or 2 or 3 or 4 or up to 10. So how can you do this? You just use the formula and you can have so probability of getting at most 10 exposed subject, probability that at most 10 exposed subject develop the disease is like this. And how can you given? When x is equal to 0, no one is having disease. When 1 plus 3 plus 4 and up to 10. So how can you compute this? This you can compute. So this, how you can compute this? How many people are there? You are testing 500 people, and number of success. How many number of success? 0 times you found disease means the number of success is 0. Probability for success is 0.5, 0.05. Number of times success is this. Probability for the failure is 0.95. Number of times this failure comes is 500. This plus if one is having the disease, number of times. So number of times success comes is 1 time. So 500, you have found 1. So this is like this. Similarly, if you have the two disease, the number of times success comes 2, 2 times. So you have the number disease and probably 2 times failure 0.95. How many times failure come? 500 minus 2. Similarly, you are getting like this. And whatever value you are getting here plus whatever value you are getting here, and once you find the summation, then you will have the answer. And it comes out less than 0.01. At home, you can determine the exact value. You are conducting a case control study. This case control study is also very important in the research. So you are going to observe, and this kind of study is generally conducted in the medical field. Case control, which is known as. So how case control is conducted? So you are conducting a case control study of smoking and lung cancer. So there are some patients having the lung cancer, okay, and people are observing that whether this lung cancer is due to the smoking or not. So this is the case. So you are is conducting a case control study of smoking and lung cancer. If the probability of being a smoker among the lung cancer cases is 0.6, probability of being a smoker means the person who is having the lung cancer. So you have seen that 0.6 is the probability that the person is smoking. This is the case. Okay. So what's the probability that in a group of 8 cases, 8 persons comes, 8, those are having the lung cancer. So how can you determine the probability less than 2 smokers? Out of 8, what is the probability that you, what is the probability of having the smoker less than 2? So less than 2 means there is no smoker, or you have the 1 smoker. So you can compute. More than 5, more than 5 means you have the 6 or 7 or 8. So more than 5, this. So how can you obtain the probability of probability that there are probability for the 6 smoker, probability for the 7 smoker, probability for the 8 smokers? How can you determine? What is the expected value and variance of the number of smokers? So first one, less than the 2 smokers. How can you get actually? You can have this. You have total number of people you are going to observe is, you have the cases, 8 cases are there. Total 8 cases there means n is equal to what? 8. And success, number of success means you are determining the smoker. So number of success in number of smokers. Okay, number of smokers. This is the smoker. The number of smokers. Okay. And the probability for the success is what? Probability for the success is 0.6. So zero, number of zero smokers. So this is you can get. How you can get zero smoker? How can you obtain this? You have the 8C, number of smoker is 0, 8C 0. Probability for the success is 0.6. Okay, 0.6. How many times success comes? 0 times. So this is 0. Multiply by probability for the failure, 1 minus 1.6, sorry, 1 minus 0.6 means this is the 0.4. And how many times this failure comes? 8 times, because 8 minus 0. So this is 8 times. And that's why the value for this is 1. 1 multiplied by 0.4 is to power 8. And this comes to this. For the next case, how 8 comes? 8 will come because you have the 8C1. One smoker you have found. Number of smokers 1. You have. So for probability for number of smoker 1. Probability for the success. And how many smokers? 1. Probability for the failure 4. Number of smoker 8 minus 1 means 7. So this is the way. Similarly, if you have the 2 smoker, then here you have the, for the case of 2, you have the 8C2. And then 0.6, 2, 0.4, 8 minus 2 means 6, like this. Similarly, if you have this one, how you can compute? 8C7, because 7 number. 8C7 multiplied by 0.6. How many times success comes? 7 times. How many times failure comes? 1 times. So you can determine this. And similarly, you can determine this. How you can determine? 8 times success comes. Means you have the 8 people and you have the number of times success comes 8 times. 0.6 probability of success. How many times? 8 times come. Probability of failure 0.4. Failure comes 0 times. And this is the answer. So you are getting like this. You can answer the question now. So less than 2 smoker. What is the probability for this? So probability of 0 smoker plus probability of 1 smoker. If you find out the summation, you are getting the answer this. Similarly, probability of the smoker greater than 5. So the probability that out of 8 people, what is the probability that we have more than 5 smokers? So more than 5 out of 8 people who are suffering the lung cancer, we need to determine that what is the probability that out of 8 people, more than 5 people are going to are habitual of smoking. So this is the case. So this probability for the 6 smoker plus probability for the 7 plus probability for the 8, and you are getting the answer like this. And then expectation formula is what? N into P. So number of, how many people are there? 8. Probability for the success is 0.6. So this you are getting. Variance is N into P, 1 minus P. So this is the variation. 8 multiplied by 0.6 multiplied by 0.4, and this. Standard deviation, you can make the square root. N into P into 1 minus P. And this is the standard deviation. So this is the way you can determine.